Welcome, everybody, and good morning, good evening, good afternoon, depending on where you are. And thank you for joining our first edition of this new training series we're kicking off in 2024. We did this last time ahead of Nodes, so there's a warm up to Nodes 2023, our online conference that happened in November. And so this time we are doing it like a, let's say, spring edition. Well, you can probably spring is close enough, so it's around the corner. So we do another set of workshops, of trainings, a little bit hands on in 2 hours time. Get some things going, explain a few concepts. Show you a few tips and tricks. Show you a few things how you can yourself be successful, how you yourself can get started with graphs, how you yourself can explore and try out new things if you haven't done so before, or if you're already a seasoned graph expert, then maybe not the session today, but future sessions will definitely be coming in handy and hopefully show you a few tips and tricks. This session today is the intro to Neo4j, introduction to Neo4j session. So we start at the very beginning, obviously, where we give you all the interesting bits and pieces you need. What is a graph? What is a graph database? What's a node? What's a relationship? What is Cypher? I haven't heard about all of these things before, so you come to the right place. If you have heard of these things before, also good. It's probably a nice refresher. So particularly if people maybe have looked at this a while ago and want to know, hey, what has changed? Maybe not so much today, but how does it all go? How does it all work? In terms of housekeeping tidbits, I would like to say that the session will be recorded, so we will send out a link to you afterwards if you cannot stay for the full time. If you miss some things, if some things were a little bit too quick, maybe, then you can always go back and watch the recording. Martin will also have a slide deck alongside his demo and his hands-on parts today. This link will also be shared with you, so you can also check that out and find out what's it all about. As far as there are links in today's session, I'll try to be as quick as possible to put them in the chat so you can follow along. It's encouraged to follow along today, and we try to make it work. But if you have any questions, if anything becomes unclear, or if you're stuck somewhere, we can try to fix it. But obviously, because it's a live segment, please be understanding that this is sometimes not possible to fix individual problems if they are, very hard to fix over remote connection. But then we would like to ask you to go to the community forum or on our Discord server and ask a question there, and hopefully the community will then be able to help you out, and we will have an eye out for this. There's also my or our dear colleague Alison in the Q&A segment. So if you use the Q&A segment in BigMarker, then just use that, type a question there. We try to answer a couple of those during breaks when we have some time, or when we come around to answer these questions. But don't be shy to use that, or just use the chat function as well if you like to say hi, if you like to say where you're from, if you like to share with us what's your graph experience. I see a couple of people here, Toronto. I see Marcella from Santa Fe, Argentina. I see Robert from Brooklyn, New York, who is pretty new to graphs. Some basic tutorials, Oslo, Norway. So a couple of people around the globe. Offenbach, Germany. Hi, Sven. Welcome. So yeah, good to see you all. And I think with that, I'll hand it over to Martin, who will lead us through the session today. I'll be obviously around, but just not visible. So have fun, everybody. Enjoy the session, and see you later for Q&A, for questions, or just in between. I'll pop up again.
Thank you, Alex. Thank you and welcome, everybody. So this is going to be an introduction to Neo4j. There are going to be some practical elements to this workshop, so there'll be lots of opportunities for you to join in and have a go. You don't need anything other than a computer or a laptop with a browser, and presumably if you're watching this stream, you have those things. So I want to just start off, first of all, by doing a little bit of an introduction about me using a graph. So this is me. My name is Martin O'Hanlon. I am a person, and my name is Martin O'Hanlon. And I work at a company called Neo4j. Neo4j, Neo4j's mission is to help the world make sense of their data. And actually, if we have a quick look at Neo4j, we can see that Neo4j was founded in 2017 in the city of Malmo, where it is also located today, and Neo4j also has an office in London. It was founded by multiple people, one of those being Emil Efron, who also works at Neo4j, who is our CEO. Neo4j is a graph database. Now, I wanted to kind of like describe myself and who Neo4j is through a graph, which is what this is. Okay, so what are we going to do today? We are going to look at some concepts. We're going to look at some data modeling. We're going to do some Cypher. So we're going to do sort of reading, writing, some aggregation, and kind of use Cypher to answer some questions. And if we have time, we might look at vector indexes. Anyway, those are the things we are going to do. So let's sort of kick off straight away with nodes, relationships, and properties, the three tenets of Neo4j and graph databases. Nodes are typically represented with circles, and graphs are essentially consists of nodes, and these nodes represent things. They represent entities. Now, in this case, it's a movie. It's the movie Toy Story, but it could be a product, a car, a location, a customer, something physical. Yeah, and nodes represent things. And we can identify these nodes or group them using labels. So in this case, this node, Toy Story, is a movie. Nodes can be identified by one or more labels. So this is a movie, but it is also an animated movie. Nodes can have properties, such as in this case, like title, when the movie was released, the plot, or anything else that you think is important to store alongside that entity, that node. And no properties are essentially key value pairs, a key, a value. Now, the power of graphs comes in the relationships between the data. So we have a node, which is our Toy Story node, which is a movie. And we could have another node representing an actor or a person. In this case, it's Tom Hanks. Now, in terms of relationships, there would be a relationship between the actor Tom Hanks and the movie Toy Story. Because Tom Hanks acted in the movie Toy Story. And every relationship has a type. In this case, it's acted in. Tom Hanks acted in the movie Toy Story. And that is the sort of grounding point of graphs: nodes, relationships, and properties. It's also really important to note that relationships have a direction. So Tom Hanks acted in the movie Toy Story. Toy Story didn't act in the person Tom Hanks. So relationships have direction. Now, the role that Tom Hanks played was that of Woody. And like nodes, relationships can also have properties. So relationships in a graph are real things. Right? And this is a key difference between particularly relational databases and graph databases. In relational databases, where relationships are essentially abstract, between a primary key and a foreign key, relationships are real things, and relationships can hold data. So we can understand more about our relationships. So let's just kind of recap that for a second. So we have two nodes. We have the actor Tom Hanks. Tom Hanks acted in the movie Toy Story. Nodes can have labels. Relationships have types. Relationships have directions. And nodes, relationships can have properties that describe or hold data about that entity. I think the first thing we should do is have a go. Let's explore. So what I would like you to do is to sign up and create a sandbox, and I'll kind of go through this process with you. So first of all, what is a sandbox? A sandbox is a Neo4j database, which you can access through sandbox.neo4j.com, where you can create projects. So what I'm going to ask you to do is to go to sandbox.neo4j.com. You'll have to sign in. You can sign in with Google, or you can create an account. And there's a box to create a new project. I want you to scroll down to recommendations, dataset, and kind of click create, and that will create a new sandbox. Now, the point I want to, one of the things I just want to draw your attention to at the moment is Sandbox will typically create a new database very quickly. One of the ways it does that is that we have a big pool of databases sitting ready to go, and we've increased the pool for this stream. Lots of people have turned up for this stream. I'm really hoping that I've increased it by enough. So there is an element of first come, first served, but I'm pretty confident that there will be enough in the pool. And if there isn't, you'll just have to wait a little while that sandbox is being created. Okay, so I'm going to leave that slide on there for a second. And I'll just kind of point out, if you go to sandbox.neo4j.com, scroll down to recommendations, and there's a little button called create, and that's going to create you a recommendation sandbox. I'm just having a quick look just to kind of make sure there's no questions coming through. It seems all right. All right. So let's just have a quick look at Sandbox. So once you've logged into Sandbox, this is what you see, and this is the button where you can create your new project, and you can scroll down to the option that says recommendations. It's normally about here. I have already created one, which is here. And once you've created your sandbox, you can then open that in the browser. I will occasionally just go and find my notes. So this is Sandbox. So it's opened up what's called the Neo4j browser. So this is a way of interacting with a Neo4j database. And when we created that recommendation sandbox, it created a Neo4j database with some data in it. Now, it's actually data that you can use to look and create a recommendation system. But what we're going to be doing today is we're just going to explore that data. So if we click on this database information box, we can see the labels of the nodes that are in this database. We can also see there are 28,863 nodes in this database. And this is a really simple way just to kind of navigate the data within Neo4j. So I'm just going to click on movie, and it's going to go off and return.
Quick question, Martin, because I just seen a couple of people asking this. If they are on Aura free, is what you showed today also possible if they have an instance already and want to follow there, or do you recommend using Sandbox?
Essentially, you could do the same with Aura free. One of the things that's missing in Aura right now is the ability to be able to pre-populate data or populate data. So if you wanted to kind of see the recommendation data, I would create a quick sandbox, and that's going to allow you to kind of like just pre-populate the database with this recommendation data really quickly.
Yep, cool. Thank you.
Okay, sorry, I've forgotten where I was. So as we can kind of see, there's this is 25 nodes, 25 movie nodes, and if we can click around, we can see. So this is the movie Nixon. We can see some information about that movie in terms of its properties on the right hand side. So we can see its budget was. That looks like $44 million, but might be I'm pretty sure it's $44 million. And we can see other information as what languages it was created in, what its plot is, a link to a poster, when it was released, its runtime, and kind of so on and so forth. So we have nodes. Nodes have labels. In this case, the Nixon node has a label of movie, and that movie has a number of properties. Now, if we select one of our nodes, one of the things we can do when we just sort of navigate in the graph is we can use this button here, the one that looks like a graph, to expand the graph, and that's going to show us the relationships between Nixon and all the other nodes in this database. And one of the things we see is that so, for example, Anthony Hopkins, there's a node called Anthony Hopkins, and there is a relationship to the Nixon movie which is acted in, which is similar to what we saw. So Anthony Hopkins acted in the movie Nixon, and we can see that the relationship has a property which is the role that he played. We can also see that there are lots of other nodes who are users. Oh, so I just clicked on this user Leslie Bentham. Leslie is somebody that rated the Nixon film, and it suddenly exploded with all of these relationships between Leslie and probably all the films that Leslie has rated. Now, Leslie has obviously rated a lot of films because we've got a huge number of relationships, and we're also getting relationships not only between Leslie and the movies that Leslie has rated, but also between the other users that rated Nixon and also rated the films that Leslie has rated. So very quickly, what we're seeing is an expansion of this graph in terms of understanding relationships. So I'm just going to give you a couple of minutes to get yourself set up with a sandbox. And what I'd like you to do is do what I did. Go to this database information tab, find a node label, click on it, find a movie and expand the relationships for that movie. Maybe find an actor, expand the relationships for that actor. And I'm just going to give you a couple of minutes to have a look at that. And while I do that, Alex, did we have any other questions?
So yeah, maybe maybe this was the camera was in the way here for how to find the recommendation sandbox. So I'll
shift
this over here quickly so everybody can see it. So if you go to sandbox.neo4j.com or the link I put in chat and then click on new project, or if it opens up, it probably just gives you this selector project view directly, and then make sure that you don't have this at the very top. It says for developers or for data scientists. Make sure you don't have the for data scientists checkbox clicked, because otherwise it'll filter you specific sandboxes for data scientists. Don't click that. And then if you need to scroll down a little bit, so it won't be right at the top. You need to scroll down a little bit, and then it says recommendations, where the arrow that here is on the screen. Then you need to click that, and then you click on create. I hope that should sort things out now.
Yeah, hopefully you've been able to kind of get to the sandbox, create a new project, and sort of find that recommendations. And like I say, I would just encourage you just to have a look at the data. Whether it's a movie node, in terms of having a look at the movies, or whether it's an actor, and expanding the relationship. So who have I found here? I found an actor called Albert Austin, which I have picked by random. I don't know Albert Austin, but one of the things I find quite interesting, he was born in Birmingham, England, which interestingly, so was I. So let's find out about a little bit more about Austin. Oh, he acted in one movie, which was a movie called The Immigrant, which I must admit I haven't seen. It is released in 1917. Well, there we go. I have learnt something today. The actor Albert Austin came from the same city as me. One of the questions that I get asked reasonably often is, or that I think there's a kind of misconception is people often think that relationships are like one-to-one. So one node can have one relationship to one thing. So for example, Robert Taylor acted in the movie Waterloo Bridge, and actually one of the kind of powers of graph is that relationships you can have multiple relationships between nodes. So for example, Robert Taylor may have acted in Waterloo Bridge. Had he also been the director of, you could have a second relationship which would have said Robert Taylor acted in Waterloo Bridge, but Robert Taylor also directed Waterloo Bridge. So we can have multiple relationships to describe, to help us understand the kind of the connectivity between our nodes. I think one of the things that I think is also kind of worth pointing out at this point is that obviously nodes have properties, which we talked about, but node properties can also have types. So just a quick look down here. We have numbers. Obviously, we have strings. We also have dates and date times, and we also have things like lists. Node properties are not simple key value pairs. There is a type system that sits behind that, and obviously all the functions that you would expect in order to be able to in order to be able to interact with types, such as extract relevant entities from dates, or doing mids on strings, or doing contains within strings, things like that. Great. Alex, does it kind of look like people are moving forward?
Looks like it. Maybe if you could show one more time how you get to where you are currently, so that we
Sure.
From the top maybe exactly, and
Sure.
then so that people are actually seeing what needs to be done here.
Okay, so if we're in Sandbox, we're going to use the button here to create a new project. The recommendation project will appear about here. Once you've created a recommendation data set, it disappears from this list, unfortunately, so I can't show it to you. But it will, once you click create, it's going to go through a process of creating you a recommendation sandbox, which is just a Neo4j database with some pre-built data in it. And then once we have that sandbox, we can then open it with our browser. It may ask you to log in if you haven't already logged in, because there's two levels of security. One are supposed to access Sandbox, which is the website where you can kind of create your Sandbox databases, and one to actually log into the database itself. So it may ask you when you open it to say, "Oh, can you log in?" But once we've done that, the first thing it does is it pops up a guide. So Sandbox has got some built-in guides. But what we're looking for is this database information tab here, and this allows us to kind of just sort of very quickly explore the data within our sandbox.
Cool.
Okay, great. I mean, so hopefully you have had a chance to explore. What we are going to do now is something I just wanted to point out. I was sort of clicking around here. When I click on actor, this query comes up, which says match open bracket n actor return n limit 25. That is a Cypher query, and that is exactly what we are going to talk about next. We're going to talk about Cypher. So I need to find my right window. Okay, so Cypher is a declarative language that allows you to identify patterns in your data using ASCII art style syntax consisting of brackets, dashes, and arrows. We're going to talk about what that means, but find the person node who acted in movies. So let's just kind of go through that. Let's break that down. So Cypher is a that's quite hard to say, declarative query language that allows you to identify patterns in data. So declarative language express the logic or what you want to do without having to describe the how or the control. So if you're familiar with SQL, SQL is a declarative language, just as Cypher is. We use Cypher to identify patterns. So patterns through nodes and relationships and properties, using an ASCII art style syntax. So if we look at our query here, our match query here, the brackets represent nodes, so they're round. That's the way I like to think about it. We define we define labels within our brackets, so we are looking for person nodes or movie nodes. The dashes and the dashes represent a relationship. So in this case, there is a relationship between person nodes and movie nodes that we are looking for. The square brackets define the type of relationship that we are looking to find between two nodes, and the arrow defines the direction of that relationship. In this case, from person node to movie node. We've got P, R, and M. So variables can be defined when we're creating our match, and we can use those variables to refer to those entities. So in this case, P short for person, R short for relationship, or and M short for movie. So that's how we pattern match. That's how we describe nodes relationships within a graph using Cypher. So to do that, we need to add clauses. So if we're going to read from Neo4j, we would typically use a match. So we're going to match person nodes that have a acted in relationship to a movie node. So it's going to match that pattern. It's going to find all the person nodes, all the acted in relationships that that lead to a movie node. And we can filter. So we could use a where. So we could say where m.title equals Toy Story. Yeah. So m referring to the movie node. So where m equals Toy Story, filter all of the movie nodes to just the ones that say to just the ones that have the title Toy Story. And then we can choose what to return. So we match, we find a pattern, we filter if we want to, and then we return the data we want to return. So in this case, we want to return the name property of the person of the person node, and we're going to call that actor, and we want to return the roles from the relationship. Yeah, and we're going to call that roles. If we were to run this this piece of Cypher, what we would see is a list of the actors who a list of the people, the person nodes who acted in the movie relationships, and we would see their name labeled actor and their role labeled role. And if you're familiar with SQL, match is very similar to from join or from and join. We define where we want to get data from and the relationships at the same time in terms of doing that match query. Where is where, and return is equivalent of select. Quite often, if you're very used to SQL, it can feel sort of upside down. Where in SQL you would define your select first and say, these are the things I want, this is how to find them, and this is how I want to filter them. So let's go and have a look. So I'm going to go back to my Sandbox. I've realized I've closed this, so it's made it a little bit small now. So I'll make that a little bit bigger. Okay, so let's write some Cypher. So the first thing I'm going to say is I'm going to say match P person. So I want to match all of the person nodes. And I want to return P. So what I'm going to ask this to do is match all of the person nodes, yeah, which are going to be returned as the variable P, and then I'm just going to return P as part of my query. So I'm going to run that, and I'm going to get a lot of nodes back. going to get a lot of nodes back. Apparently running quite slowly. I do. Oh, there we go. Now, okay. So there are a lot of actor nodes or person nodes in this graph, and it's limited it to the first 300. Yeah, but it's matched person nodes and returned them to me. It's only displaying the first 300 in the graph, but as we can see, they are nodes that we can see. So we can filter that. So let's put a where clause in. You're welcome to follow along with me if you've got your sandbox open. I do have a few tasks for you to do after I've done this. So if you feel like you want to watch me first and then have a go, we can absolutely do that. So I can say match the person. I'm going to put a where clause in. So I'm going to filter it to say filter by Tom Hanks. And I get one node back, which is Tom Hanks, which is, and we can see all of the relationships for Tom Hanks. So we've looked how we can match a person, we can filter a person, and how we can then return it. Something that I've realized that I very quickly skipped over is when you're writing a query in Sandbox, it tends to all be on one line, and if you press enter, it will run it. If you want to put it on multiple lines, what I tend to do is if you do shift and enter, it will put in a second line. So let's match a relationship. So what I want to do is I'm going to use a relationship. So I'm going to change my match. And I'm going to say, let's use that acted in relationship. So I'm going to say match all the person nodes who have acted in, and then I want to return the movie nodes. So, and I'm going to filter it by Tom Hanks. And what I want to return is I want to return the person node, which is this case is Tom Hanks, but I also want to return the movie nodes, in which case this is hopefully all of the movies that Tom Hanks has acted in. Okay, and what we do is we get a graph that represents that Cypher query. So here is Tom Hanks and all the relationships that Tom Hanks and all the movies that Tom Hanks has acted in relationship to. We can flip that around. Oh, actually, one of the things I'll do is there are. So where clause is a really kind of powerful filtering system. You can do, less than, equal to, or, and so on and so forth. If you just want to filter on single values, you can also filter directly in your match query. So you can say name is Tom Hanks. It tends to be if I'm just filtering on a single value. This tends to be how I run my queries. But let's just flip that around. So actually, I don't want to just Tom Hanks. Let's say I want all the person nodes, but I want them for a particular movie. So I'll just change the filter. I'm going to say title, where the title of the film is a movie called Twister. And again, what have I done here? Title, movie, Twister.
The curly bracket after person.
Right. Who can see what I've done wrong here? Oh no, I've left that. Yeah, thank you, Alex. There we go. So I can flip that query around. So rather than filtering on person, I'm now going to filter on movie. But again, it's going to show me the movie Twister and the acted in relationships that take me to person nodes, albeit they're being back. They are backwards. So I'm just going to rewrite this. So what I want to do is I can say, okay, let's match movie nodes, and I want to find all of the people who acted in the movie Twister that we've just seen. But then what I can also do is, and again, because Neo4j is kind of built on relationships, I can also say, okay, well, tell you, if those people that acted in the movie Twister, use that acted in relationship to go off and find all of the movies that those people acted in. So I'm going to have to call this M2, movie 2. And then I can return the person, the movie Twister. In fact, let's make this make more sense. Let's call that Twister. Let's return, and we'll just call that M for movies. So what we're going to do is we're going to return Twister. So this is the single movie twister. We're going to return all the persons who acted in that, and then we're going to return the movies that those people acted in as well. And we start to get a graph that looks like this, right? So it's all centered around twister. Yeah, so we can very quickly expand the relationships from one node to other nodes to understand more about our data. And again, what we might want to do is actually, I don't want to return a graph. Every time I return, what Neo4j is doing and what browser is doing in this case is it's representing the data that's been returned as a graph, because what I've asked it to do is return nodes. So it assumes I'm asking it to see a graph. However, behind the scenes, this is just text. This is just data. In fact, it's a JSON data. It's just JSON data. And sometimes I might not want all of the information. So let's just say, actually, what I actually want is I want the names of the people and I want the titles of the movie. So I can say p.name and p.title. Name and title being properties. Name is a property of person nodes, and title is a property of movie nodes. And again, I can get a list, so something more something more like a record set. So it goes through Helen Hunt, goes through Carrie. I don't know, Carrie. Anyway, whoever carries, and Bill Paxton, and so on and so forth. So let's just take a breather here at this point. And I'm going to sort of throw it back to Alex again. Alex, do we have questions, thoughts, things that we need to address before we let the good people of this stream have a go?
Yeah, I think it's good. I was a question on from Kong, but I think you kind of like answered it already by showing the table format. So basically, just to help out for people who are used to seeing more like a table view, how does this compare to the graph view? But here it is on screen.
Yeah, yeah, and like I say, like the data that's returned when you run a Cypher query is actually just like a JSON data set that you can read in the programming language of your choice. But what browser's doing is because I'm asking it to return nodes, it's rendering that as nodes to kind of give me I suppose a friendlier view to kind of like interpret my data with.
And then there was one question on the last query you just wrote. If you could send me that,
this one
in the private chat, and then I can share it in the chat with the audience, so then they can perfect. They can copy this and don't have to.
So things that I feel I should point out, that because and there are things that I always forget to point out, is case sensitivity. So movies different. Movie with a capital M is different to movie with a little m, and actually you'll get different results. So labels are case sensitive, as are properties. And again, that's something I always forget to mention, and something that trips people up.
Yeah. And one question from Richard: how are they stored as JSON as well? I guess talking a little bit about how does this all work in.
I'm probably not the best person to ask. It's definitely not stored as JSON. It is stored as a native graph data format. Neo4j isn't a graph database that's sitting on top of a relational database in a kind of like pseudo way. It is a native graph database. I'm probably not the best person to ask in terms of the internals of how the kernel works. But yeah, I would love to send you to a link to documentation.
Yeah, I think we will have to do that. Also on the architecture of the Neo4j database, I think it'll be not really what we can cover today. Unfortunately, there's lots of material out there on this, and like you said, I think it's a native graph database. It has all the bells and whistles that any other proper database have, so you can use it fully application ready in any form or function you need it to work for you. But today I think we cover more like, okay, how do first steps work? How do you write a Cypher query? What is a node? What is an edge? Stuff like that, and the actual architecture, how it all comes together, I think is probably something we have to defer for today. I'll dig up some links and share them in the chat.
So yeah, I wanted you to have a go. So if you've got yourself a sandbox open, there are a couple of tasks, and I'll give you a few minutes to do these. So the first one is like, look, just find a movie you like. So there's a Cypher query to do that, which will return you a list of movie titles. And then I have provided a scaffold or part of a Cypher query that I would like to challenge you. I'm not sure challenge is the right word. Give you the opportunity, right, to have a go and complete complete that Cypher query and give it a run. So there's one about using so use the acted in relationship to find who acted in a movie. So very similar to the queries that you've just seen me write. And then one of the things we didn't talk about there is also a directed relationship. So there's a directed relationship between movie and person nodes, and that will show you, or that will reveal, that relationship there will show you who directed the movies. So yeah, I'll give you you all a couple of minutes to have a look at that. And we probably should have done those questions after I set people with a task, Alex. I wonder if there's any more.
Yeah, that's a good point. I just dug up the link to the internals page, which I'll post right here. There were a couple of other questions. Let me see if I can, because Alison swiftly took care of all of them and
Of course
answered
she did.
everything.
Of course she did.
So I need to follow through here and see what else there is.
So just while you're kind of looking at that, again, sort of based on experience, there are definitely a couple of things that people have said to me in the past. So when doing matching, and you've kind of got this like match person nodes, going, is there a way to match on more than one node? So so match person or user nodes, and actually yes, there is. And I'll just very quickly put the syntax up for that. So you would do match p person, and then you'd use a pipe character to say or user, and that perhaps makes more, if it's say, if you've got a graph of employees and customers, so match anybody who is an employee or a customer. So that's certainly one of the things that's been asked of me in the past. So you can do or, so you can say like a employee or a customer. You could also do and, so you can use an ampersand rather than the pipe character to do and as well. So you can say match person. So find me all the nodes who are person nodes and they are employee nodes, so they have both labels on them.
Cool.
That's certainly questions that have been asked of me in the past as well.
Yeah, there was one question on the direction of a relationship. Are they going from one direction to the other, or are they bidirectional, or how does this work?
So relationships always have a direction. So when you create, and we'll kind of move on to creating and writing data into Neo4j in a moment, but when you create a relationship, it always has a direction. It goes from one node in a direction to another. Interestingly, when you write queries, you don't have to specify the direction when you write a match query. You can leave the direction out, and Cypher will find its way. However, there is a relatively big performance hit in terms of doing that. So if you know the direction of a relationship, it's always a good idea to use it. But relationships have to have directions.
And actually, it's a good point from Alex. The challenge number 2 you wrote on the screen is missing a curly bracket.
Oh, look at that. Sorry, there should be a curly bracket here.
Yeah, exactly right there.
Well, I left it in, just to make sure people were paying attention.
Yeah.
No, I didn't. Genuine mistake. I left it
on 3 as well. So you.
I was on, and I have done the classic program mistake of copying pasting
copy and
something.
paste your errors. Yes. Yeah. So if you do this and you're stuck there, then use the closing curly bracket after the the question mark block.
Interestingly, I've also left it out of my my solution too. So if we let's just kind of have a quick look at question number 3, which is using that directed relationship. So we're going to say like match. If we want to use a directed relationship, we can say like match. Okay, in fact, I forgot. What did I say? Use a direction. Find who directed a movie. Okay, all right. Yeah, so let's match the movie first. And we're going to say title. I'm going to use Twister again. That's going to be my go-to movie, I suspect, for this stream. And we're going to again, as we used it acted in before, we can use directed. Now the directed relationship goes this way, so it goes that way, and we want to find the P person node. And then we can just say, we'll just go return P. And it was Jan de Bont. Excellent. Okay, well let's just return that as a list. So we'll do the movie title and the person name. Yeah, Twister was directed by Jan de Bont. Alex, I'm going to ask for an opinion because you're kind of seeing all the chatter going through. Do you think we're in a good place to move on?
Looks like so. I mean, I see a couple of people try this. I see there's another comment from Judith on the node type names are case sensitive.
They are, yes. Yep. So
maybe we talk a little bit about what is and what isn't case sensitive.
Yeah. So we'll use this as an example. I would go for it is case sensitive. There you go. Everything is case sensitive. Labels are case sensitive, as are properties, as are strings. Yeah. As are relationship types, as are variables. So and I suppose it's just kind of like what would happen if I said that I get nothing back, right? So if I miss out a capital M, it's basically said, well, hang on, there are no little m or lowercase m movie nodes, so the match doesn't work.
Yeah. And then there's another question. I mean, we can spend lots of time or little time on
Hours.
it.
Let's have another minute, shall we? Let's have another one.
Is Neo4j is it used in any real world scenarios? Come in from Chandra. So
I mean, of course. I would direct you to neo4j.com in terms of looking at who our partners are. Lots of very big enterprise organizations use Neo4j, particularly when looking to kind of make sense of their data. I don't know if Alex, is there a use case that you really like that we could talk about publicly?
There are lots of. I mean, yeah, it is a wide field. So I mean, recently, lots of things happened around knowledge graphs with the Gen AI story. I think that's become very popular. But this is probably maybe goes too far. Finance use cases, financial institutions, governments, banks, insurance companies here in that space. Lots of pharma companies. So I like that space a lot. I think that's a cool place because I think it usually brings forward everybody because it helps find cures, new applications for existing cures, things like that, research and drug discovery. So that's helpful in the healthcare industry as well. Patient journey is a cool industry, a cool use case, or telecommunications, right? Think about networks. If you are a telco company, you have routers, you have networks, you have antennas, you have switches, you have whatever else, clients. That's all forms a network basically. And if you want to track this, if you want to make sure, okay, if you switch this server into maintenance mode, who is going to be affected? This is a graph query. So you can see lots of applications, lots of real world scenarios, and I'll share the link to our.
The ones the one I like is around things like manufacturing and things like bills of materials.
Yeah.
So I don't know. Let's say you're BMW and you're building a car, and you have a supply chain problem with an M5 bolt that attaches to a gearbox, understanding what that supply chain issue will have in terms of your manufacturing chain. You know, how is that bolt used within the kind of the myriad of manufacturing processes that you have? So it's not going to affect the building of a particular car, but it could be the building of engines that go in lots and lots of other cars that you hadn't been able to kind of realize before.
Yep.
Shall we move on?
Yep.
Okay, let's do that. Okay, so what we were looking at there in terms of like using Cypher was around reading. So we're going to move into writing. Getting data out of Neo4j. Let's kind of look at putting data in. So again, we use patterns that kind of look similar to what we've seen or seen before. And merge is a really typical way of creating nodes. So merge will create a person node with the name Tom Hanks. And actually what merge does is it finds or creates. So if there is already a person node who has a property name Tom Hanks, it won't create it. It will re-reference that existing node. There is an alternative, create. Tend to use merge. It's a good idea because it allows you to deduplicate your data. So merge is how we create nodes, and it doesn't matter whether they're person nodes, movie nodes. That's how we create nodes. It's also how you create relationships. So first merge creates a person node with the name Tom Hanks. The second merge creates a movie node with the title Toy Story. And we can see that merge returns a reference to the node that was created or found. And we can use merge to create relationships between them. So we use merge to create an acted in relationship between the person node that was just created and the movie node that was just created. And there is a set as well. So in terms of creating properties, so in this case, we're going to create a property on the relationship. So we're going to say set r.roles equals Woody. So we have created a person node called Tom Hanks, a movie node for the movie Toy Story. We've created a relationship that says this person node acted in that movie node, and we're going to add the Woody. We're going to add the roles property to the relationship. And if we wanted to add additional properties to Tom Hanks, I don't know, the year he was born, we could do set p dot year born to whatever year Tom Hanks was born. I have no idea. So that's the kind of the premise behind creating nodes in Neo4j. All right, so what I'm going to do is I am going to go through creating myself as a director. Why not? I've always wanted to be one. So let's create me as a person in Neo4j. So the first thing I'm going to do is I'm going to say merge, and I'm going to create a new person node. And I'm going to create it with my name. Like that. And I can run each one of these individually, but actually what I want to do is I also want to merge. I want to merge the movie. What movie shall we create for me? I mean, I'm going to call it
the Graph Academy.
Tech Lesson 1. Graph Lesson 1. That's better. Yeah. Or even, I mean, my introduction to Neo4j would have been so much better. Let's do it. Because that's where we are, right? Yeah. To Neo4j. So we're going to create that as a movie. And I'm going to say merge. And then I'm going to create a relationship between. So I'm going to say I acted in that movie. Right, and that's it. Right, so I'm going to merge person node, and I'm merge a movie node, and then I'm going to merge that relationship between the person node to say that I acted in, and I need to give it a direction. Martin acted in the movie Introduction to Neo4j. And if I run that, okay, right. I mean, so it's giving me some VP, 2 labels created, added 2 labels, created 2 nodes, set 2 properties, created 1 relationship. So I know it's done something. Let's go and find me. So let's just write a quick match query. I mean, it doesn't make it any easier because I have an apostrophe in my name. Let's just find me and return me. So here I am, and then with a bit of luck, there we go. There is a new movie called Introduction to Neo4j. Okay, well, that's great. So we created a person node, a movie node, and then we created a acted in relationship between those 2 nodes. I'm going to do something which isn't on my script, but that's the way things go. Let's live code. So Alex should be here, shouldn't he? Alex is the director of this party. So what we're going to do is we're going to match name Alex. So we're going to merge a new person in called Alex. Now, I want Alex to be the director of the Introduction to Neo4j movie. Now, I don't need to. I could merge that movie in again, and again, because I've used merge, it wouldn't create it. But you know what? I know it's already there, so I might as well just match it. So I'm going to merge me. I'm going to merge Alex, and then I'm going to match the movie. So the title is Introduction to Neo4j, and then I'm going to merge. So I'm going to then create a relationship that goes from Alex. It doesn't help that I always use P. I'm going to call it A for Alex. And Alex, not acted in, directed this movie. And what have I done there? Right. So I gotta say, all right, I'm going to use merge because I don't want to get into a conversation about with just yet, but it will do the same thing, right? So interestingly, what we can see now is added 1 label, it's created 1 node, and it's set 1 property and created 1 relationship. So we can see it's only created 1 node, which was Alex. It has reused the Introduction to Neo4j movie node and has created that relationship. So let's just go and find Alex in the same way that it found me. Alex, there he is, and there is the Introduction to Neo4j movie, and there is the relationship between me and Alex on the Introduction to Neo4j movie. Okay, so what I'm going to do now is again, I've got a similar thing. I've got a slide where you can have a go. So similar thing as before. Hopefully, I haven't got any syntax errors in here. I've got another one there. Look, I've obviously got a bit of a blind spot of missing out curly braces because I've missed one here. Anyway, so I'd like to have a go. So I'd like to create a node for yourself. So you're going to use merge. You're going to merge a person node in, and you're going to give them your name, and then you're going to give them, and then you're going to give yourself a role in a movie using the acted in relationship. And then finally, final one is just go back and actually try and find your role in that movie. All right, Alex, do we have questions that we can have a chat about while people are going through this?
There's one question that Dean asked, but I guess we come to that a little bit later. When you want to have, you showed us a little bit when you, let's say, have me and you query in one string.
Mm-hmm.
How do you work with the variables? Do you just use P1, P2, or is there another way to get to 2 different, let's say, 2 different persons, or it could be 2 different movies in the same statement.
I think what you're saying is like, so say there was
say match me and match you, but we use in the same statement, so we use two different variables, I guess, for the two persons.
Yeah, I mean, I suppose what we could do is we could say match person, yeah, and we could say where p dot name equals Alex, or p dot name equals Martin. Oh, hang on. And if is that what we think people mean?
Yeah, probably. I mean, this is
Okay.
another good
Right.
way. I didn't think of this right away, but yes, totally. I mean, this works.
Yeah. Yeah. I mean, yeah. Or to your point, you could do this as well. Yeah. You could do Alex. So we could say, this one would be Alex. And then this one would be Alex and Martin.
Yeah.
I wish I'd just put Martin in rather than Martin and
Exactly.
In
further down, other statements, you don't want to go to with and all that stuff, but right down, and you can just use A and M as placeholders.
Yeah, so yeah, we could absolutely do match different nodes, and like let's go mad. Let's do Alex while pickle works with M. There we go. We created one a relationship. In fact, we should probably go the other way as well, shouldn't we? So M works with A, and again we can kind of run queries like that. And what we should see is, if we then return those two nodes, we can see that there's relationships between those two things. Anyway, sorry. Well, I was meant to leave you on this slide and I forgot.
Yeah, cool. Then there was a question on size of a graph. Is there an upper limit? Is there, is there?
I mean, of course, in any scenario, there will be an upper limit. However, if you have the money and the means, billions of nodes.
And then there was another question on where to deploy Neo4j, or where to when Sandbox or desktop are like for individual, for test runs and for experimenting, but where does it go?
I mean, generally for deployment, I would obviously recommend our cloud service Aura. That is the far and away the easiest way to stand up a Neo4j database, fully managed service, with a variety of kind of cloud platform providers as well. In terms of like personal, like local development, there are kind of a number of options. Not Sandbox. Sandbox is a sandbox. It is a place to play. Yeah, it's good for kind of training and understanding. You can run enterprise Neo4j on your local machine. I do quite often when I'm doing testing. I'd also encourage people, if you are kind of moving into doing your own development, the Neo4j desktop is a good solution as well. Mainly because of its ease of use, and it's very easy to kind of like stand up new databases, break destroy them, back them up, restore them, without having to stand up a kind of full Neo4j enterprise environment. But yeah, absolutely can do. Neo4j works very well in Docker. Tends to be my kind of like default if I'm building an application which uses Neo4j.
Yeah, cool. Yeah, so I mean, anywhere where you can imagine deploying a database, I think you can bet on that Neo4j will be available to do so. So yeah, I think that should not be should not be an issue for you in actual environments. There was another question on, are the nodes and relationship labels predefined at some database creation time, or can we create new ones on the fly? So
you can create new ones on the fly. You can create them, label them whatever you want, and nodes can have as many labels or as whatever labels that you want to give them. Neo4j doesn't set out a conformed what are the words I'm trying to find here, Alex?
constraint or
Yeah,
schema?
yeah. It doesn't define a data model that you are constrained by. Yeah. So if you want to create a brand new node with a brand new label with a collection of properties against it, you can do. Just merge it in, set those properties, and Neo4j will store it and create it for you. In the same way that I just created 2-person nodes and created a brand new relationship of works with between me and Alex. Yeah.
If you want to create those boundaries, though, on the other
Yes.
side,
So
totally cool to set
yeah.
that up and then create these constraints and limit it to. There's with the recent version, I think version 5, a couple of new additions to constraints have been added, so you have even more flexibility there and be more rigorous on certain nodes require certain properties, require relationships, and all of that stuff. So it can be relatively set, but technically it also very free.
Yeah, exactly. Yeah.
Yeah.
Yeah. So typical constraints being, if you create a node, it must have a certain property. Very good for things like IDs. Yeah, and as you said, Alex, if you create certain nodes have to have certain relationships as well.
And maybe one more question on because we often are here in this in these challenges or in these little exercises, we ask for certain names or titles and stuff like that. Is there something like fuzzy matching if you aren't quite sure about how things are written, or if there are options?
Yes. So if you wanted to do things like we're saying in this example or in previous examples, match a person, you have to give them a very precise name. Again, the options that you would expect to find in most query languages about things like contains or like breaking down that case sensitivity. So those, absolutely, those options exist. Yeah.
Yep. Cool.
Shall we move on?
I think we can move on. Yeah. Yeah.
Okay. All right. Lovely. Hopefully you've all had a chance to have a go. So I want to talk a little bit about data model, just because I think some of what we've been talked about around this kind of like data model that we've been exploring has been implied in terms of what node should be and what labels should be. But I'm just going to go through that. There's a function within Neo4j, which is db.schema.visualize. So in the same way that you've been writing match and merge queries, if you put that into the browser, you can output a schema that describes the data that is within Neo4j at that time. So actually, I'll just do that. Call db.schema.visualization, and we can see that we get a schema out. Now, I've got a new relationship here, which is work which is the one that I just created that goes from person to person nodes. But we can see the data model that's in the sandbox that we are using, and we can see that there are node labels of user, actor, director, genre, person, and that one should have movie written in it. I've obviously done something wrong when I've exported that, but yeah, that is a movie node. And there is a sort of like golden rule that we try to describe, which is nodes should be nouns, and relationships should be verbs. So a person advertised on this platform. but it's all kind of, it's also really important to know when to kind of break that rule. So for example, we may need to build out on this network, but based around this fact that this person advertised on this network, so we might want to do person purchased advertisement on platform. And again, I would consider that to be a suitable use of kind of node names and relationships, but typically noun, verb, noun is a great place to start, and that will kind of really help you think about what your data is and how you might model it within Neo4j. There is a temptation, particularly if you've already got data that's in a kind of like tabular format, whether that's in a relational database or I don't know, a spreadsheet or a CSV file. There is that temptation to try and model your graph to look a bit like your tables, and actually I think it's always worth taking a step back and just going, actually, well, what are my entities here? What are the things, what are the nouns, and what are the relationships between those things, and how do I express them as kind of verbs? And using that, you can expand from nodes through the relationships to kind of like really get a good understanding of what that data looks like. We have briefly talked about this, but one of the things I just wanted to kind of point out is that properties are not set. So we've got two person nodes here. We've got Martin and we've got Alex, and while these person nodes have a name property and a lives property, as in where we live, those properties are not set, as we talked about. You're not constrained. So if you want to add in properties to certain nodes but not into others, that's fine. And if you do things like match queries and you go and pull back properties that don't exist, you're just going to get a null value. It doesn't say, there's no error to say that property doesn't exist. You just get a null value saying that property doesn't exist, or there is no value for that property on this node. All right, cool. So I was going to move on at this point to answering questions, not answering questions, as in me answering your questions, how you would answer questions using Cypher and Neo4j. But is there any questions that anybody has just on that kind of data modeling piece before we move on?
There was one, maybe, which should be a quick one, is Richard asks, what are the two buttons we see when we click on a node in browser, and what do they mean?
Oh, I don't know. Hang on. Hang on. So let's get some data back. So do we think Richard means these buttons?
I think he means, that's probably what he means.
Okay.
So. I hope so.
That one expands the relationships from that node. So that one expands relationships. That one hides. Yeah, so just gets rid of it. And that one locks it. So it'll always be there. Is it? I thought that would have. I'm not sure actually.
It should mean that.
That's what I think it does.
Yeah. If you click, well.
See, now I'm not sure.
I'm not sure either.
I'm going to go find out, because that's what I thought it did.
Yeah.
But I must admit, I don't use it very often.
Yeah.
So now I'm like, have I got that right?
It
must be. It must lock it, and then i.e. you then can't move it. As in you can't remove it from.
Exactly.
Yeah. From that display.
But yeah, I mean, don't be shy if you click on something in browser. That's not a query, then you cannot break anything. You can wobble around with you in the view. You can change the view. You can dismiss nodes. If you just rerun the query again, everything will be back to what you in the visual part of it comes back to you. So yeah, that was a question.
Is it? So I think the question was, what is that? The A colon.
Pardon?
Sorry, I just saw a question come up. Don't worry.
Yeah.
Don't worry.
Yeah, question: when you hide a node, how do you unhide? Well, just you can always rerun that same query, and it won't create duplicates. It will just send it back.
Okay, yeah. So I can see a question coming through. Somebody's asking what is, I think, is what is the meaning of like the a colon. The a colon is giving a variable to what is returned by that match query. So if I want to refer to the nodes that are returned as part of that match query, I need to give it a variable, and the variable I've just called it is a. I mean, it could be anything. I mean, it's this node is always going to be Alex, so I could call it Alex, and then I'll just return Alex. Just means that I can refer to it later within the query, or I could do alex.name and m.name. Yeah, it's a way of referring to that node.
Yep. There's a good question come in from Dean. Can I bulk build a Neo4j database by importing a CSV or something else from my existing data I have?
Yes, absolutely. And I would encourage you. I did a stream maybe 2 months ago, exactly on that topic, which was importing CSV data into Neo4j. It's actually based on a Graph Academy. So Graph Academy is our online training platform, free training platform, free courses, free certification, and there is a course called importing importing CSV data into Neo4j. Yes, absolutely. There is a Cypher query called load CSV, which allows you to bring in a file and then refer to that, and use merge to create nodes based on the data that you read from a CSV file.
Absolutely. Cool. Do you want to continue, or shall
let's
I?
let's carry on.
Yeah,
we
good.
can always go back, can't we? Okay, so answering questions. So let's kind of have some fun with Cypher, and let's think about what is the best Matrix film. So kind of what I want to do here is let's just kind of talk about how we would use Cypher, and kind of like use some of the use the query language to answer questions like what is the best Matrix film. Now the recommendation set that we've loaded contains persons and movies, which we've talked about. We also briefly saw users. There's a collection of nodes which are all users who have rated films, and those ratings came from the IMDb database. So what we're going to do is we are going to work out what is the best Matrix film. Right. So the first thing we need to do is let's do some. So what we're going to do is well, first of all, we need to match some movies. We need to find the Matrix movies. So I'm just going to very quickly let's build this up piece by piece. So I'm going to say, right, match movie nodes where the title contains Matrix, because I'm pretty sure all the Matrix films had Matrix in the title. But what we'll do is we'll then just do return m.title. Right. Okay, brilliant. Okay, we've got three Matrix films: The Matrix, The Matrix Revolutions, and Matrix Reloaded. So we've matched our movies. In order to kind of work out which is the best, we should look at the ratings that people have made. So there is a rated relationship. And the rated relationship goes between movie nodes and user nodes. And user nodes are users who are, users of IMDb. So we can find, we can return the film, and let's just do you.name. So the names of all the people that rated them. So these are all the people that rated those films, of which there are probably a lot. Okay, so let's continue to build up this query. So now we've got movies, users who rated the Matrix films. What we need to do though is that the rating that a user gave a movie is actually a property of the rated relationship. So it is, I'm pretty sure it's just r.rating. Yeah, that's looking pretty positive. Okay, so here we are. Here are all the Matrix films, all the users that rated. those films and the rating that they gave them. So if I want to find out the best one, what I probably need to do is I need to average out I need to average out all of those ratings. So I'm not interested in like individuals anymore. I just want the average rating. So I can say, okay, well, there's a function called average, AVG, and if I pass that, that'll return me that rating. Okay, so we've got a rating out now. That is the average rating of all the ratings that for those movies. I'm just going to tie this up a bit and just call that average rating. I'm just going to give it a label. Might as well neaten both up as well, rather than m.title. Let's just call it title because that's what it is. So now we get the title out and the average rating. Now we can see that actually the Matrix, so the first Matrix film, is the highest rated Matrix film. But let's just order that. So what we're going to do is we'll say we'll order that by average rating, and that's going to give us. Well, it's going to give us it the wrong way round. So let's just stick descending on the end of it. And I think if you're used to other query languages, particularly SQL, this is probably going to start to look sort of familiar. Okay, so we asked ourselves the question: which is the best Matrix movie? Well, based on the ratings given by IMDb users, it is the Matrix, the first one, and I'm pretty sure the Matrix Reloaded was the second one, and I'm pretty sure Matrix Revolutions was the third one. I think that what that says is the original is always the best. Let's just have a quick look at that query because I went through that really quickly. Right, so we do a match. We say, right, match movie nodes through get the rated relationship from users. So what I'm looking for is I'm looking for users who rated movies. And I'm going to filter that by, I just want the Matrix movies. So I'm going to filter that by any title that contains the text Matrix. And then I'm going to return some data. I'm going to return the title property of the movie node. And then I'm going to get the rating, which is the rating that this user gave this movie, and it is stored against here, against the relationship. And if you think about, okay, well, why would you store rating against a relationship? Why wouldn't you store the rating against the user? And well, it's because a user could rate a movie more than once. And yeah, that's it. And then I use the average function to work out the average of that, give it a label, and then I'm going to order it by the average rating, and I'm going to do that descending. And that gives me all the Matrix movies by their average rating. So I have again set you up a little challenge, right? Which is can you use the rating property on the rated relationship? So there is that rating property that we looked at that's on that rated relationship to find the movies with the most ratings. So how many movies, or what's the most rated movie? Might not be the best or the worst, but what's the movie that had the most ratings? And I've included as we used the average function, I've included the count function, which is going to allow you to sum up the number. Again, yeah. So write this query, fill out the blanks, and then actually, can we look and say, okay, well, what were the top 10 movies based on average rating? So we're going to expand that query that we looked at before, which was just for the Matrix, and say, actually, how do we get a top 10 based on average rating? And I'm introducing something new, which is limit 10. So what limit does is limit says don't return me all of the rows, only return me the top. So in this case, the top 10. Okay, I'm going to take it back to Alex. It's like, again, we've got this sort of pause point where can we answer any questions?
Yes, I think we can.
Ooh.
There is one question from Eric, and he asks, can you use Python to create or query a database?
Yes, absolutely. So there is a Python driver. There are also Python drivers for most popular applications. Most popular programming languages. I'm going to get them wrong, but certainly Python, JavaScript, Java, Go. Have I missed one? There's more. C. Is there a C one?
Well, there are a couple of community ones.
Yeah,
.NET
I
is
suppose they are.
official. C, I think, is community driven. Spring Data is more or less Java, and then there is GraphQL as well.
Yes. Yeah.
So officially supported, and then there are a bunch of community drivers like C, C Sharp, and others, which are supported and developed by our community, but are not officially a Neo4j product. So that means the performance and the depth in the integration might vary depending on the PHP one, for example, is pretty good, I think, because that's a community member. Glenn is doing that, and he's taking care of that. So I think that should be very far in terms of feature matching, but some others might be very rudimentary.
Yes, but I think the answer to was it Eric?
It was Eric, yes.
Answer to Eric's question is yes, absolutely. Yeah, and for most popular languages, there are there are drivers, for to kind of make that process simpler as well.
Yeah. And there was a question coming from SQL. Looks like the group by movie was performed automatically. I'm not really somebody that works with SQL, so I have no idea. But maybe you know this.
Yes, I think is the answer to that question. Yeah. So by using a function that groups that groups a result set, you automatically get that grouping.
Cool. And then there was another question on your query you just showed earlier, where the table was revealed or returned as a result. You can always add more columns to a query like this.
Yeah. So I don't know. Let's say I want to get the plot out for each one of those. I would add, m.plot. I want to get the plot property from the movie node. Yeah, so I get title, plot, and then scroll along. We'll find the average rating as well.
Exactly. So it depends what kind of data you have in and what properties are set. But you can create a pretty big table and add all of them. But here we just show obviously just a smaller part of it, because the plot is a good example. I mean, it might be interesting for some, but most of the time it probably is just a huge string that gets in the way.
Yeah, exactly.
And then there was one more question from Richard here. And that's, I think, a little bit from where we talked about the data model and the relationships a little bit earlier. Shouldn't lives be a relationship and not a property? And probably the answer will be it depends. So in this case, I would say it made sense to split it out. But sometimes, if your data model doesn't need it, or if your queries you don't need it, then you can totally include that as a separate property. And you think, okay, imagine a person node, and you just put the address. For example, let's talk about a customer set. Maybe you have a person, and that's Martin, and then lives in London, High Street 1, something like that. And because you never look for that, but if you have like a database where you oftentimes go around, okay, who lives in the same city, who live maybe even in the same street, or maybe that's important, then it makes sense to spin that out and make separate nodes and individual relationships to that. So it quite depends on the actual things you want to do with your graph database, and that's why you decide how to put the things in one node or in a relationship or a property.
Yeah, absolutely, Alex. Yeah, it entirely depends on what you're trying to achieve. Whether something should be a node or a property. Yeah.
Cool. I think that's all for now.
Okay.
I think we can continue.
Oh, let's go. All right. Okay. So, sort of moving on with that theme of sort of answering questions. So, hang on. So we have got, as we've been kind of talking about, graphs help us understand relationships. And one of the things that you can do with graphs is that you can look at paths between data. So what we're going to do is we're just going to have a quick look at at shortest paths. So what we're going to do is try and find the shortest path between Kevin Bacon and Al Pacino. I picked two random actors, and it worked out quite well. So what we're going to do is we're going to try and find, actually, what is the connection between Kevin Bacon and Al Pacino? Have they worked together on films? What film might that have been? So the first thing I need to do is I need to find Kevin. So let's find Kevin Bacon, and I'm going to create. I'm going to match the node. So let's just find Kevin Bacon. And then, just because I'm slightly, let's just make sure that is actually Kevin Bacon. Oh, what have I done here? Oh, I've missed that. There we go. Okay, right, I can find Kevin Bacon. That's good. All right, let's find Al Pacino. Let's call him LB, LP even. Person, name, Al Pacino. Let's return Kevin and LP. All right, brilliant. We've got two nodes, two different people. What I want to do is find out actually, what is the shortest path? What's the shortest path through the relationships that we have in this data between those two people? And there is a function called shortest path that allows us to do that. So what we're going to do is we're going to match. We're going to say, right, I want to find a path, match a path, and that path is going to equal, right, the shortest path. So shortest path is a function that returns a path. So we're going to say shortest path. Shortest path requires a path. We need to tell it what I'm trying to find the shortest path between. So the shortest path is going to be between Kevin B. And I need to tell it some relationships. Now I could give a relationship type, but actually at the moment I don't care. I just want to find within all of the data that we've got here, what is the shortest path between these two nodes, or in this case, these two individuals who happen to be Kevin Bacon and Al Pacino. So here's the path that I want to find between these two nodes. And then once I've done that, I'm going to return P. So P is that shortest path. And let's give that a run. Right. Okay. So what it's done is let's just have a look at this graph so we can see what we're doing here and what it's done. So it's found Kevin Bacon, it's found Al Pacino, and it said, okay, well, find me the path which is the shortest path between these two nodes through any relationship that you can find. And then what it said is, okay, well, Al Pacino acted in the movie Heat, which is part of the genre action movies. Kevin Bacon acted in the movie Trapped, which is part of the genre action movies. I'm not completely convinced that is a good connection between those two individuals. Just because they both acted in an action movie, that doesn't feel enough for me. So what I'm going to do is I'm going to change this query and say, not any relationship, because it's picked up this in genre relationship. Let's be specific and say it has to go through the acted in relationship. Right. And let's just give that a run. Okay, that feels better. Right. Kevin Bacon acted in the movie Sleepers. Robert De Niro acted in the movie the movie Sleepers. Robert De Niro also acted in the movie Heat. Al Pacino also acted in the movie Heat. So the link between Kevin Bacon and Al Pacino is Robert De Niro. That's how we can find the shortest path between those two individuals. So there's a couple of things I just want to kind of point out here. So shortest path returns the first shortest path it can find. So there could be more paths between Kevin Bacon and Al Pacino which have less relationships between them, or sorry, the same number of relationships between them, but it's just going to return the first one. There is another function called all shortest paths that will return all of them, and then you can obviously kind of interpret that data. There is a change here that I've expressed in the relationship where I've added a star, which sort of made sense when I didn't have a relationship type in there, all relationships. But actually what the star does is it says take as many hops as you want. So as many, it could be a million relationship hops. It doesn't matter. Star is as many as you want. And what we can do with this is we can actually express, well, if it's more than 5, I'm not interested. If it's more than 5 steps away, or it's more than 10 steps away, I'm not interested. So that allows us to express the number of relationships between people. And shortest paths are a very useful function of graph databases. Particularly if you're trying to work out. Actually, I don't know. Let's put this in the context of customer management. Where you want to understand actually how are 2 customers related, or what's the link between these 2 customers, which may support things like recommendation engines. If you also think about things like crime investigation, shortest paths where you can do things like say, okay, I've got a logged crime, this sort of felony, another logged crime, this sort of felony, this sort of individual. We'll find me the shortest paths between them. And actually you may find, well, this individual who committed this crime, this individual who committed this crime, they have a relationship with another criminal. And actually that starts to allow you to build up kind of networks and understandings. Okay, so that's shortest paths. So just to recap, in this case, I want to find the shortest path between 2 nodes. So I match those 2 nodes. Match P. So P is just the name of the variable. I could have called it path. I could have called it Kevin B to Al Pacino. That's just the name of the variable. And then I'm going to use the shortest path function. Shortest path requires me to give it a path, as in, where are you looking? In this case, it's from two very specific nodes through an acted-in relationship, and the star means you can take as many hops as you want. And actually, one of the reason it's got a kernel on is it's actually telling me the provided pattern is unbounded. Consider adding an upper limit. It's basically saying, you've said go through as many as you want. If I'd put 10 in there, it'd gone, oh, that's fine. There we go. Okay, so that's shortest paths, really useful function. And again, I have got a little task for you.
Yeah, before we do that, there was a good observation from Eric also in the chat. It's not that you just defined a relationship or a pattern without defining the direction within.
Oh yes, yeah, yes. So because I'm looking for because I'm looking to find the shortest path. Actually, I don't care what way that relationship goes. And actually, if we look, the acted in relationship goes through this movie Sleepers. And there's an interesting thing, which is when you create a relationship, it has to have a direction. Right? There's always a direction with a relationship. However, if you query, you don't have to specify a relationship. In actual fact, I could have done like that. So that is the simplest, right? But again, by giving a relationship type, I'm narrowing the focus of my query. By giving a direction, I'm narrowing it even more. And if you're giving a relationship type, you will almost always know the direction. Yeah. So relationships have to have directions. When you query them, you don't have to specify the direction. However, if you do, you'll have a much more performant query.
And there was a good observation from Roger I just like to read out, because I think it's probably will resonate with lots of people who are working with relational databases. Just so you know, doing this in SQL is extremely slow and complicated because you have to join the same few tables over and over again an unknown number of times to achieve the same result.
Cyclic joins in relational databases are a real headache, and more often than not, well, certainly in my past experience, it's been I'm just going to change my data model because I know this isn't going to work. Yeah. And that is a big differentiator with graph databases is they are built to understand relationships.
Yeah, thank you for that comment, Roger. Yeah, we can continue.
So yes, I want to. We're back onto have a go. So again, what I'd like you to do is to look and find the connection between two movie nodes. So find two movies you like, match them, and then use that shortest path to find the relationship between nodes. The other thing I would like you to do is there is a user called Angela Thompson who has rated movies. I would like you to find the connection between this random user, Angela Thompson, who I literally just picked a user node at random, and Kevin Bacon. Right, Alex, is there more things we're talking about, or is it have we run out of questions?
We can talk about more things. There was another discussion about the actual movie ratings of between Matrix 1, 2, and 3, and if they were slightly skewed. So I think let me scroll to the conversation here a little bit, because the first Matrix movie got over 100 reviews. The second movie got 50 or something, and the third one only got 30 or something. And at least in our, I mean, this is just a snippet of the data, but
Yeah,
it's just an excerpt, right? So please don't be if
I mean,
Matrix movie is your favorite movies of all time and you're pissed off, please don't. this is this is just an example, but yeah, I mean, it could be, and there's you average might in this case be not perfectly true, so maybe you want to bounce it against the number of reviews and get that average afterwards to even out a little bit across the number of reviews and the number of movies. But for this exercise, I maybe would have gone a little bit too far. But yes, you're right, in terms of the numbers and the dates.
Yeah, so yeah, I mean, it is a problem faced with trying to analyze data, isn't it? Depending on the data that we have. I mean, you could look at it another way that says the third movie was so bad that people couldn't even be bothered to rate it.
Sure. Yeah. But they still made a fourth one.
Did they really? I've no idea. I'm
That's
kind of
not
wishing I hadn't picked
another,
Matrix now. It feels
yeah.
like
There's that was, what was it,
maybe
last year, I think. Yeah.
maybe if I'd gone for the Jaws films or Alien, maybe, or something like that.
Yeah. Yeah. We could go into, well, any best practices for improving data load. I don't know. That is something we really didn't cover or won't cover in this episode today. Again, maybe the shout out to the one episode where we run through the CSV import and bit on that, and obviously shout out to the Graph Academy. I don't know if you have ad hoc few recommendations you wanna put there.
I think, I mean, my starting point would be only load the data that you need to load, right? Yeah. So if you can do deltas and things like that, do deltas. That's always a good first start. If you have less data to load, it will take less time. I think batching transactions is a good idea. If you are loading from CSV, you can use the kind of buy transactions to chunk up that data. I think those are the things off the top of my head. The other thing I would really encourage people to do is when you run a query in Cypher, you can put profile in front of it, and this will actually tell you the run profile of that query. And generally, the bigger the orange bar, the slower that part is. And actually, through query tuning, you could definitely improve your load times.
Yep. And then there were a couple of questions on, or I saw a couple of comments, and because you just mentioned it here with the acted in star sign, what is how does Neo4j work with wildcards? Can you use wildcards? Can you use something like it? I mean,
Yeah, yeah. Yes, you can. I'm trying to think of like good examples. I mean, like, let's find another sort of slightly less. I don't know. So if we wanted to do say like that. Oh, I always thought you could do that. Maybe you can't. Oh, hang on, you can do that.
you could just do, yeah,
yeah, and that will return everything. So you can in terms of like string matching, again, use kind of wildcard characters. I would not like to live code that right now because that feels like something that I'll definitely get the syntax wrong for. But the Cypher manual covers all of those things.
Yeah, absolutely. Cool. I think we talked a little bit about this. Mikolas asks about constraints and rules on data. I think earlier maybe you missed this. You can totally define, besides doing an index, which we all recommend doing, you can, at the same vein, basically, when you start setting up your database, you can define constraints on nodes, on properties, on relationships, and you can define that how your schema kind of like should look like, if you will. Like Martin said initially, you don't have to do that if you don't want to. You can be free as a bird and do whatever you want. But you can define certain rules and limitations and constraints on your database, and that might make sense for your application and for your use case. So the option is there. It's just not enforced out of the start, basically.
What's our sort of time looking like?
So we have 15 more minutes.
Okay,
Give or take.
Okay. All right. What I think I'll do then is I'll move on to talk about vector indexes. I think we can probably just get this in 15 minutes, and then maybe have like a couple of minutes at the end. Vector indexes are something relatively new to Neo4j. I think they came in 5.11 in beta, and then 5.13 in kind of like production. And I just want to kind of like start by talking about semantic search. So I just kind of want to run through an example of where vector indexes are useful. So if we think about semantic search, and I kind of pose this question: Apple, technology or fruit, right? So semantic search is the process of trying to understand search phrases' intent or contextual meaning, kind of rather than just focusing on individual words. So traditional search would like often depend on like exactly matching keywords or sort of proximity based algorithms to find similar words. Like, for example, if you inputted Apple into a search, you might get predominantly get results about the fruit. However, in semantic search, it tries to gauge context. Are you searching about the fruit, the tech company, or like something else? So if you added in Apple stock, Apple stock could refer to the fruit or the technology company, but it probably refers to the technology company in terms of financial stock and stock market shares. So we're going to look at an example of like semantic search. But let's talk about vectors. So vector indexes allow us to find the distance between vectors. Now, vector is simply a list of numbers. So for example, the vector 1, 2, 3 is a list of 3 numbers that could represent a point in 3-dimensional space, right? And you can use vectors to represent different types of data, not just points in 3D space. That could be text, images, audio, and using vectors with dimensions of hundreds or even thousands. In machine learning and natural language processing is like really common. And like like, and when we refer to a vector in the context of like machine learning or natural language processing, the term embedding is typically used. So an embedding is a vector that represents the data in a useful way for a specific task. So, each dimension in a vector might represent a particular semantic aspect of a word or a phrase. When multiple dimensions are combined, you got all these dimensions of the kind of meaning of a word or a phrase. So, for example, the word apple might be represented by an embedding with like dimensions for fruit, technology, color, taste, shape, like not an infinite number, but lots and lots of dimensions. I think the embedding model from OpenAI is something like 1,536 dimensions. But you can create these embeddings in various ways, but the most common way is, as I sort of mentioned with OpenAI, is to use a large language model. And the way that vector search works, or vector indexes work, is they look to measure the distance between two vectors. So what I want to do is just sort of a bit of an activity at the end. Is I have taken all of the movie plots from I've taken all of the movie plots and I have added them to a CSV file. In fact, interestingly, somebody was asking, how do we load data from a CSV file? This is exactly what we're going to do. Is we're going to load some data from a CSV file. In this case, it's the plot embeddings. So I'm going to quickly go back to my Sandbox, and what this is going to do is it's going to download this file, which is all of the embeddings for movie plots. Well, it's the first 1,000 anyway. So it's going to download this file, which is a CSV file, and then it's going to match. So it's going to find the movie that's got this particular movie ID. Talked about using match before, and then it's going to call this function which sets a node vector property. So it creates a property on these movie nodes called plot embedding. And then it uses this function here. The embeddings in this CSV file are actually like a JSON list. So I'm just converting them into something that we can use. So anyway, I'm just going to run that, and what it's going to do is it's going to go off and it's going to hopefully create 1,000 properties. I'm assuming that has done it. In fact, let's just have a quick look. So if I just match movie title Toy Story return if I look at this now, what we should see is this plot embedding. So all of these numbers that we kind of talked about, all this vector that represents this plot, and the thing that we can do with our embeddings is that if we create a vector index, we can use that vector index to look for similarities between things. So I'm just going to create a vector index in my Sandbox. So now I've got all my embeddings. I'm going to say, right, create a vector index. I'm going to call it movie plots. I realize that we've moved at speed in terms of what Cypher looks like, but I think for the point of this creates a vector index. And we're going to create it on movie nodes. We're going to look at that plot embedding, so that list of numbers that we created. And I've got some options here. The first one being how many dimensions are in that vector. Well, there's 1,536. I created these embeddings using OpenAI, and it's asked him. And I'm also going to set a similarity function. So there's cosine and Euclidean, which is algorithms for determining distance between vectors. So I'm just going to create that vector index, which it did pretty quickly. All right. Now, once I have embeddings which represent movie plots, and once I have a vector index that indexes those embeddings, I can then use that to query and find similar movie plots. So I've got a quick query here. I'm going to take this query and we'll put it into Sandbox and we'll talk about what it does. So the first thing it does is it matches a movie node. In this case, it's the Toy Story movie. It doesn't have to be. And then it goes off and it uses this function, which is db index vector query node. So I'm saying, okay, we'll query the nodes, query the vector index we just created. I want you to return the six most similar nodes, and I want you to base that on the plot embedding that I got from the Toy Story movie. We need to yield, so return a node, the node being nodes that are most similar to this node. And then I'm going to just output the title of the most similar node, what the plot was, and what the score is. So let's run this and we'll see what it does. So I've asked it to find me, based on those embeddings, based on those vector indexes, the most similar nodes to Toy Story. Now, the most similar node, most similar plot to the Toy Story plot is Toy Story itself. And if we look, that has a score of 1. Yeah. Because it's exactly the same. Yeah. And then it tells me in reverse order, Little Rascals is considered to be the next most similar movie to Toy Story, which has got a score of 0.92, and so on and so forth. And vector indexes are a super powerful way of searching data in a way which is semantic, or is less constrained, right, and allows you to see similarity between them. And it doesn't have to be movie plots. It could be customer comments or complaints or product descriptions. So find me the products that are most similar to this one. Cool. Right, now I've rattled through that because we only have a few minutes left, but I just kind of wanted to leave you with some potential that you could take forward. And if you want to have a go at doing these queries, we can. I've included in the in the slides a link out. So this will take you to download a piece of Cypher code, basically this piece of Cypher code, to load the plot, create the index, and then query the index. All that would do. I will fix that before. I just know we had a question. Can you run it on the movie Casino? Oh, okay. It might not be one that I have created an embedding for, because I only created embedding for the first 1,000, but we'll see what happens. Oh, I did. Oh, okay, excellent. Yeah, Casino underneath Goodfellas, Pulp Fiction, Desperado, American Buffalo. Yeah, that kind of feels right. Okay, great. So I think we're about time. But Alex, is there questions that we want to talk about?
That's cool. Yeah, I mean, like Roger says, we did take quite a jump from the Cypher we were using earlier to vector searches. So I think don't be scared now, and don't be put off if you didn't follow what Martin just did the last few minutes. It was really more like to show and to give you an idea of what potentially there is in addition, because this session today was very, very intro and very, very beginners friendly, but it should not make the impression that Neo4j is only there for basic things. It can be very advanced. It can be go further into depth and can do very powerful things. But obviously, we didn't show this today because this episode is called Introduction to Neo4j, or not Advanced Cypher Query Writing with Martin. So
we can do that next time.
Exactly. So why? But don't be scared. I think but it's good to see, good to show, and great to get a little bit ahead of what there is to come. And this slide is perfect segue into that. So maybe you wanna say a few words about Graph Academy.
Yes. So what we've gone through now is as Alex says, an introduction. Talk about fundamentals. Talk about some how to get started with Cypher. I would encourage you all, if you want to learn more, is to head to Graph Academy. So it's a hands-on online training platform. It is all free, and it will take you way past what we have learnt today, including moving into Gen AI, and also into things like graph data science as well.
Yeah, absolutely. And there are many courses available and interesting. You know, like this what you show here is like almost a step-by-step guide. You start with the fundamentals, you go on to fundamentals on Cypher, data graph data modeling, then you import your data, and it's like it's a very nice curriculum to build up your skills and um, your comfortability with working with Neo4j.
Yeah, and somebody asked about integrating Python into applications. Again, there are courses on Python, JavaScript, Go, everything else, TypeScript.
Yeah. There was a question on the vectors from Yanis. Which vector index is used in Neo4j? Not super important, but just wanted to know.
I'm not sure of the context in terms of like which, but yeah, if we can get some more information, we'll answer that after
we
the
should
talk.
be able to do. But I think we implemented this in probably natively somehow in Neo4j, but I don't know the answer to this either. I must admit. But yeah, thanks for the question. Still, cool. Anything else you want to say, Martin?
No, other than it's been great fun, and I hope
Yep.
everyone's enjoyed themselves.
It was great fun. I just wanted to shout out the next couple of dates. So obviously 14th of March we did today. If you like to stick with us on the training series that's happening this week, next week, and the week after, then I invite you to register for upcoming events. On the 19th of March, so next Tuesday, we talk about how to tame your graph with Liquibase. On the Thursday, 21st, we do Mastering Neo4j deployment for high performance RAG applications, or retrieve, augment, generate. If you are into the world of AI, Gen AI, then this is definitely a must watch, a must attend, I would say. And then on the 26th, we talk about large scale geospatial analytics with graphs and the PyData ecosystem. So if geospatial data, geography is interesting to you, then this session should be one to attend. Besides that, we do regular live streams on YouTube and LinkedIn. So if you follow our channels there, give it a subscribe or a like, and then you will get notified when the next streams go live, and you can watch there from community live showcases to live coding and to interesting conversations. Everything is there. So I would invite you to join this as well. And next to Graph Academy for beginners and for advanced and for experts alike, there is our Graph community on Discord as well as on our forums. So if you have any questions, any points you want to discuss with the community, any things you'd like to share, maybe you want to share your graph, maybe you want to share your story, then put that there, or answer questions or post questions as well. That's a great place to be, and we are very friendly and welcoming everybody that is in the world of graphs. Yeah, and with that, I think we can wrap it up for today. Thank you, Martin, for the great tutorial, the great workshop today, and your live coding as well as the nice challenges. Thank you all for watching, obviously, spending the time with us, running through Sandbox, running through Cypher for probably the first time for a few of you. So thank you for doing that. Hope you enjoyed it. Hope you liked it. If anything is unclear, anything is still up for questions, then you know where to go. Graph Community as well as Graph Academy. And yeah, I think with that, wish you all a great rest of your day, rest of the week. I hope to see you next week for one of the upcoming workshops, or later at another time for a live stream. And yeah, with that, take care, everybody, and goodbye.
Bye.
Bye.